I'd like to share my screen. So the approach today is more or less to show you what is the procedure that includes to use Python scripting to create your custom.
Juan, you are in presentation mode. We just see the screen smaller. Can you?
Oh, I probably chose the wrong.
Yes, choose the right window.
Second. Yeah. Okay. You see here. Okay. Here.
Yes, that's correct.
Okay.
That's the correct one.
So, is it work if I put in presentation mode?
Yes,
yeah?
That's working.
Okay, perfect.
Thank
so
you.
The approach today is more or less to show you what is the procedure to use a Python scripting to create your geometry templates. Within JMAG, we have the possibility to create or to use the user templates that are already predefined when you install the software. So those templates can be used either for 2D or 3D models. And usually the functions that define the geometries are already defined within the scripting that, that is used for that specific geometry. So we can use different templates to create either magnet modeling, stator modeling, rotor modeling. And as I said, it is possible to use those templates to create 2D or 3D geometry. The geometry templates help the user to set individual variables to specific constraints that can later on be used for a further parametric analysis. So on the left side, we see a small picture showing how exactly a template looks when it is displayed in JMAG. And on the right side is the preview that is generated when we plot the geometry edition. So the objectives of this presentation is basically to understand the basic procedure of using a Python template for automated generation of geometries. Also to learn some of the basic API functions that are used to create these geometries, and ultimately to create a basic geometry using the templates. So one of the important points to be noticed here is that to be able to create the geometries that we want to work with using JMAG and Python scripting, we are required to use the API functions that are especially designed for JMAG geometry editor. Okay, these API functions are easily are available and easily accessible using the JMAG help desk. When we go to contents under parameter explanation, we go into the geometry editor, and into the mesh part we find user-defined template API functions and samples. This is a document that includes all the explanation on how each API function works for geometry addition and for geometry creation, such as creating lines, such as creating curves, creating edges, creating edge lists and bodies, and changing the colors of your design, and so on. All these functions are available in this user manual, and it's, as I said, easily accessible from the help desk menu from JMAG Designer. I will show you how to access them. So this is more or less how a Python scripting for JMAG geometry edition looks like, of course, with very few definitions inside. And it's divided in different, in a structure that is as shown in this list. So for the geometry template structure, the first part that we have to take into account is the definition of the geometry feature. In here, we will determine what are, for example, if we are designing a rotor, if we are designing a magnet, this is the definition of the geometry feature that we are talking about. After that, we have to add variables to that geometry feature. So let's say that for the magnet creation, let's say in this case, we want to work with the length of the magnet and the thickness of the magnet, let's say. Those are two variables that we want to add to our definition of this feature. Then we have to set labels for those variables. So it is simply assigning names to those variables. Ultimately, we will set groups for the edit panel. This is when we want to have several geometries in the same compound of geometry feature. Let's say that we want to design a rotor entirely defined by the core steel and also the magnet. It is possible to create a group for each part. Let's say one part will be the core steel, and then the other part will be the magnet. Another optional thing is to define local variables as needed. So let's say we want to work with distances, with nominal values of distances and so on. This is easily done by defining local variables. We can also start the next step is to create basically all the edges that will compose our design. So JMAG is able to create lines, to create circles, to create ellipses, to create any type of geometry entity that later on can be assigned to an edge list, which is the next step. In this edge list, we will contain in each edge list, we will include all the lines that compose a body or a sketch. And then later, after creating the edge list, we can create a body list made of different edge lists that contains the bodies for creating the regions that we will assign materials to. And in the end of the script, it is necessary to delete the list to release the memory of the compiler. Okay. Some of the API functions that are available for use within JMAG are as shown in this slide. Let's say one of them is the curve creation. We just have to provide a position. We can provide the type of entity that we are creating. In this case, is an edge. And all the arguments that will be assigned to this function, we can assign it to a list of arguments and then just include it in our definition of the curves just as shown in here, okay? It is the same procedure for a line creation, for an edge, for a circle creation, and so on. After creating, as I said, after creating each component that will form a geometry, let's say the magnet in this case, we want like 3 lines to compose our magnet. We have to create an edge list containing all those 3 lines that then later on will be used to create the region defining that magnet. So for the edge list creation, we have simply to create an edge list and add all the lines that compose that, that region or that geometry, okay? And later on, use this edge list to create a region based on those lines. And that region will be ultimately will define the geometry we want to work. More API functions, as I said, are available using the help desk and the document that I mentioned before. And you can easily access it by the path I mentioned. So we will now run a live example on how to do so. We will try to create a very small and simple geometry of a rotor and a magnet using a Python script. For that, we go and refer directly to JMAG. As I said before, when we create a model, let's simply save this. Documents. So when we create a model, we are able to go directly to the geometry editor. On the right side, we have the geometry library. Basically, all these elements that we see in the geometry library are predefined templates that you can use by just dragging and dropping. So let's assume that I want to work with a 2D model of the rotor, and then we say a permanent magnet, and just dragging and dropping. We are able to see on the left side in the model manager, we are able to see how this template works. So here is the definition of the variables that we want, and we have basically the conditions that will govern the creation of this geometry, okay? We are not able to edit this scripting here. However, we are able to import our own templates and use them as we want, okay? The template generally should be able to modify the geometry by simply changing the values on the variables setting tool tab from the left side. So let's say if we want to change here the, let's say the magnet thickness from 4.5 to 5, it should be changed automatically. And that is how a template should work. Of course, the process of creating a template sometimes can be very complex, because the idea is that we have to understand, first of all, how the geometry works and what parameters we want to parameterize. In this case, we have here DMAG, PMAG, for example, or WMAG. Those values are values that are manually set and that later on can be used for the definition of a case, for the definition of, let's say, a parametric study, and so on. Okay? So let's assume that we want to create a geometry based on this. So by importing or creating our own geometry templates, we only have to create a sketch, a 2D sketch, sorry, not this one. We insert a 2D sketch, and from the 2D sketch, we will add a template feature, and we go to user-defined region template. As you can see, when we use the geometry template or the region template, there is nothing displayed here and there are no regions that are created. This is because we have not loaded anything to the Python scripting. So when we click in edit script, the user-defined template is, scripting editor is open, and here we are able to either write ourselves the code that will define our geometry, or we can use a simple or an already generated Python script containing all the functions that will describe the geometry we want to create. We have to also, again, clarify that the functions to define this geometry have to be the ones described in the API functions. And those ones, you can just show them from here. We go to contents, we go parameter explanation. Oh, sorry. We go here. Into the help desk. We go under parameter explanation. We go under geometry editor. And here we see the user-defined API template functions. This is a PDF file that you can download. You can also dig in a little bit here, and then here all the functions are described to obtain values, to copy, to delete, and then also to create 2D geometries or 3D geometries. In this case, we can go to 2D geometries, and we see here how to create, for example, a line, how to create an arc based on a radius and a start radius and an arc center. So there are basically many functions that can be used for the definition of our geometries. It is necessary to go in deep and understand how the objects are created, how the variables are created, and which type of variables are we using in the generation of a Python script. So I have worked with a simple geometry here. I have created this geometry template, including all the variables that will be used to describe my rotor with my magnet. So I have written this in an external program, Notepad++. In here, I'm defining all my regions and all the lines. And basically what I can do is use that Python scripting and import it here into my scripting editor within JMAG. Okay, so the file to import, basically to import a geometry editor or a geometry template, we go under File and then Import, and then from here we check in the function tutorial the curve magnet, and we click play, and the geometry is automatically created based on the definition of our geometry template. As said, this is a very simple geometry. If we change, for example, the radius here, we change it to 100, it should be able to change automatically. Shaft radius, we say, I don't know, 30. Everything should be modified automatically. So if we want to change here the distance from the magnet to the pole edge, we say, I don't want 8, I want something smaller, let's say 2. And the magnet thickness, I want it to be 8, say. So you see that the geometry should be entirely dynamic. I can add as many, or I can define as many parameters inside this geometry as I want. However, one has to be very careful, because when defining this type of geometries, you have to respect different constraints that will then apply to your geometry. So there are some limits here that are not valid for the creation of the geometry. So if I define a model which is not defined well in terms of the geometric values that I want, then the geometry will collapse and it will not be created. Okay, so once I use the Python script that I want to perform in the creation of my geometry, I just click play, and then the geometry is already loaded here. And when I close it, I am able to import this geometry into the JMAG editor. I should be able to see here two basic geometries, one for the core and one for the magnet. And I can easily work on them when I import them to the JMAG editor. So once I go back here to JMAG Designer, I import my model and the geometry is easily created. I can modify here the names. Again, there are API functions that will save you time when changing, for example, the name here. I say magnet, and then, no, this is rotor core, for example, and this is magnet. I can easily, for example, change the color here of the rotor core and change it to steel. And then the magnet also, I can change the color, let's say to blue. And this is how it works, the creation of the geometry. There are some other features here that we can show. I can also combine my own created geometry templates with the ones that are already embedded in JMAG. And for that, it is simply, the idea is to simply use the geometries that we have. Let's say this is the same geometry I created. And if I want to use, for example, the rotor description that is already here on the geometry templates, I can do so. And all the variables will be already described. And I am basically using the geometry I created. This is a very simple process. It's a very nice feature that, that not everybody knows. However, it requires practice because it's not that simple. But it is very useful for those who want to automate the creation of geometries based on their own designs. And if they don't want to work with external geometry editors or CAD functions. So I think this is basically what I wanted to show today. And does anybody have any questions regarding the process here on how to create geometry using Python templates? Or
Thank you, Juan. We will switch now to questions. So far, we have no questions. So if anyone has anything to comment or a question, please ask them now. Seems everything is clear and no one has a question.
In any case, if anybody has any question later on, the questions can be done after the session, and we can go back to you with the answers if you have any query regarding this feature from JMAG. Okay.
Okay.
So I think that was it. And I would like to thank everybody for attending to this presentation. And I encourage you to follow the next presentations that will take place at 3 p.m.
Yeah, I can show the schedule.
Yeah.
So we will go into the break now at 3 p.m. We will have a PSIM implementation of dynamic model of three-phase induction. Speaker is Danilo Camuglia from the University of Catania. At 4 p.m., we have additively manufactured copper windings, calculation process, optimization potential by Dr. Jacob Young from the TU Freiberg. He's also the CEO of his own startup, Additive Drives. So very interesting topics.
Yeah,
Okay.
excellent. So, okay.
I think that's it then. Thank you very much for attending.
Okay.
And I hope we will see you in this afternoon again.
Thank you very much for paying attention to this presentation, and hope to see you later on further presentations.